Hello everyone, welcome back to Kognito Key. Today we have a really fascinating explainer lined up for you. We're going to be looking at the fundamental backbone of modern telecommunications, which is, of course, radio signals. Specifically, we'll be decoding the technical distinctions between amplitude modulation and frequency modulation, or as we all know them, AM and FM. But before we dive straight into AM and FM, we have to address a really fundamental hurdle. You might be wondering, why can't we just send audio signals directly through the air? Well, human voices and music are low-frequency signals. If you try to transmit them directly over long distances, they suffer from rapid attenuation and heavy distortion. Basically, the signal just dissipates before it ever reaches the receiver. It completely falls apart. And that brings us to the core mechanism that solves this: modulation. Modulation is the process of superimposing our low-frequency information signal onto a high-frequency carrier wave. Think of it like this. The low-frequency audio is your fragile payload, and the high-frequency carrier wave is a sturdy, high-speed transit vehicle. By combining them, we can transport that information over massive distances without any degradation. All right, let's jump into Section 1, our very first solution, amplitude modulation. The physics behind AM are actually quite elegant. We start with a high-frequency carrier wave, and we keep both its frequency and its phase absolutely constant. The only parameter we modulate or change is the amplitude. So the height of the carrier wave rises and falls perfectly in sync with our message signal. That means the changing amplitude is what actually carries our data. Now, AM became a massive worldwide success for a few key reasons. It boasts a brilliant transmission range, and it operates very cost-effectively in the medium and high-frequency bands, roughly 535 to 1705 kilohertz. However, it definitely has some fatal flaws. AM has a very high susceptibility to environmental noise, and it suffers from severe fading. If you've ever driven your car through a bad storm and heard your AM radio suddenly dissolve into crackling static, you have experienced this flaw firsthand. Which brings us to Section 2, the evolution, frequency modulation. So how does FM shake things up to fix those static problems? Well, in frequency modulation, we literally flip the approach. The amplitude and the phase of the carrier wave are kept entirely constant this time. Instead, we cleverly modify the carrier wave's frequency to match our message signal. When the message amplitude is high, the carrier frequency increases, which compresses the waves together. And when the amplitude falls, the frequency decreases, spreading them apart. This shift in methodology was a huge game changer. Where AM suffered from severe fading and high noise interference, FM is vastly more resilient. Because the data relies on the frequency rather than the amplitude, random environmental electrical noise hardly affects it during transmission. Combined with simpler circuitry requirements, this high signal-to-noise ratio is exactly why FM became the absolute gold standard for broadcasting and satellite communication. Let's put them head-to-head in Section 3, the AM versus FM showdown. When we look at the scorecard and compare the two directly, AM is definitely the more cost-effective option to implement, and it wins on raw transmission range, traveling massive distances. However, it operates on a fairly narrow 30 kilohertz bandwidth. FM, on the other hand, requires a wider 80 kilohertz bandwidth, and it is more costly. But because of that wider band and its incredible immunity to noise, FM completely dominates when it comes to crystal clear sound quality. So, what is the final verdict? Well, it ultimately depends on your engineering requirements. If your main goal is long-distance transmission while keeping your infrastructure costs down, amplitude modulation remains highly effective. But if your top priority is rich, clear sound quality with minimal distortion, frequency modulation is the clear winner every single time. With digital streaming taking over our dashboards today, you really have to wonder, how much longer will these analog airwaves remain a part of our daily commute? And what new modulation breakthroughs are waiting just over the horizon for us? I hope this explainer made the complex physics of radio signals crystal clear for you. If you enjoyed this analysis, please hit that subscribe button to join the Kognito Key family. Give this video a big like, share it with your friends and network, and I will see you in the next one.